Okay, so we're going to go ahead and get started here. My name is Caleb Madrigal. I'm presenting. I'm actually going to be I'm going to be doing two very small talks. Things have gotten a little more crunched for time with lunch being a little bit late. So I'm going to be talking about two disconnected topics. So the first is Hypervault. I'll talk about that first. Also, there's the QR code, by the way. And also, I'm going to be talking about tunneling. We'll see how much time I have to cover those, but yeah, we'll just play it by ear. You guys got that QR code? Okay. Waiting for the QR captures. All right. Okay. So anyway, I'm here from the Milwaukee area, part of the DC 4 group. So by trade, I'm a software engineer, but I'm kind of having a focus. I'm kind of focusing in security. So right now I'm working at Mandiant, which is it's a subsidiary of FireEye as of like 3 years ago. So working on some cool stuff there. So Hypervault. So Hypervault, I'm going to start off by way of demo. So Hypervault is a file encryption app. It's a web app. It's kind of different than a lot of others. So the first thing I want to show about it is it actually is a completely self-contained .html file. So there are no external JavaScript files, no external images, CSS, anything. So for that reason, we can actually just hit File, Save Page As, and we can save it. I'm just going to save this to my desktop. And you can see it right here. So this HTML file, it's just a file. I can open that up. I'm going to close the web one out now. So you can see it's just a file running off in my browser off of my computer's hard drive. So no connection to the web is needed. It doesn't go out. It makes no external calls. There is no server-side component to Hypervault. It's served on GitHub Pages. It's purely static. Okay, so anyway, let's demo what it actually does. So let's say you have some files you want to keep private. You could have image files or whatever. You can just drag them in here. You can also like insert text. So hi, which is actually really helpful in some situations where if you have some kind of secure data, a lot of times you don't want to put it in a unencrypted file on your computer, so you can just put it right in line into Hypervault, and it'll encrypt it. So once you have all the files that you want to be in your locked vault, you just set a password. And click Lock Vault. And as you can see, it's doing some crypto stuff. It's doing some things like it's doing some password-based key derivation functions, key lengthening things, scrypt. So that makes it more difficult to brute force. It also uses, we'll go into this in a bit more in a minute, but it uses 3 different ciphers, one inside the other. So it should be very secure. In theory, if 2 of the 3 ciphers are broken, you're still safe. All right, so you can see that it outputted, it downloaded this locked vault 83.html. So at this point, I can close down this app, and I can just click on this file, or actually, I'll just show you. So it's just here in my downloads folder. So I can double click on this, and it opens up a locked Hypervault, as I refer to it, in your browser. Again, totally client side. So I can put in a password if it's the wrong password. It'll try to decrypt it. It uses a method or a message authentication code, so it knows if the password is wrong. And here I'm putting the right password. It's decrypting and you can see the output here. So, you know, so I have a couple files that you can view them just in your browser rather than ever downloading them if you want. Or if you want to download it, you can just click download. It'll download that to your desktop, and you can open it from there. So back to the... So the URL is hypervault.github.io. So just the standard GitHub like server pages, github.io and Hypervault. So again, what it is, it's a file encryption app. And one of the things about it that's kind of unique and different is it packages, you know, if you look back at the file that it outputted, the locked vault, this file contains both the entire Hypervault app itself as well as your encrypted file data. So if you go in there and look at it, you'd see your encrypted file data in variable and then just the software to decrypt it. So this has a couple nice advantages. So one of them is you never have to worry about your software getting out of date. So if you have some files that are really important to you, you know, you may encrypt them with some other software, but what if that software goes away, or what if the version, it gets out versioned? Hopefully they're doing backward compatible stuff, but there's always that risk. A couple other advantages to it are there's no installation needed, right? So it's just you can go to the site in your browser and you have it. You can also just from there download it offline and you have it indefinitely. You never have to go to the website again. So it's got a really low barrier of entry. I see this as being kind of a really simple way that, let's say you have some non-technical friends, and you know they don't have GPG, right? They're not going to install GPG. You know, maybe they have hard drive encryption, maybe not. So this would give a pretty decent level of protection to them. If they use it the right way, it should give a completely state-of-the-art level of encryption. There's some caveats which I'm going to talk about in a minute. But so that's kind of the idea. And like, so an ideal use case in my mind would be like, let's say you have a USB drive that you just want to keep some data on, and you know you're probably not going to do drive-based encryption on that USB drive. You know, if you want it to work on multiple different computers, you may not be able to even install software on all the computers you might want that to work on, perhaps. So that's where Hypervault would really come into play at. So what Hypervault is not, I don't know what happened there. There we go. So what Hypervault is not, so Trenton back there, if you heard any of his last talk, so he had a really good demo of how not to use Hypervault. So Hypervault's meant to provide data at rest security. It's not meant to provide data in transmission security. So the crux of the matter is, if I send a Hypervault over the wire, because that contains both the code and the encrypted data, there's a chance for a malicious attacker to change the code, basically. And oh, sure. How's that? Okay, that's fine. So now there is one way you could potentially use Hypervault for data in transmission, and that is if you know like the MD5 or the SHA-1 or SHA-512 of that encrypted Hypervault. So like, and really if you're sending data to someone else, you would need a way, if you're trying to use Hypervault for that, you can do it, but you'd have to transmit the password out of band somehow in some secure way. So this is not asymmetric. You know, you'd have to get that information to them securely. And if you did that, you could also, I guess, give them the MD5. If you do that, it should be totally secure as long as they're checking the MD5 before they run it. Anyway, that's what. So Hypervault's not meant to replace, you know, secure data transmission crypto. So a couple things that I want to highlight again that's awesome about it. So Hypervault uses the TripleSec library. So I looked at a bunch of different JavaScript crypto libraries when I was researching this. I looked at like Crypto.js, the Stanford one, SJCL, I think it's called. And I kind of like, tested them for speed, feature, security. TripleSec is the one I came out with. So it uses AES, Salsa 20, and Blowfish, or Twofish, I can't remember which, to encrypt, one inside the other. And it's a great API, it's a great library. So like with some of the other libraries, like the Stanford one, they give you all the primitives, and you can tie them together. So the key derivation functions, that kind of stuff. But it'd be up to you to do that. With TripleSec, they basically say, we think this is probably the best way to do crypto, and so we're just going to give you a function that does it the right way. So you just give it basically a password and the plain text, and it encrypts. So pretty sweet. Also, since Hypervault runs in a browser, one nice benefit of that is that it's sandbox. So if you were using Hypervault, the worst it could do is not secure your data, which would be bad, but you know that it's not going to be hacked and then doing anything nefarious potentially on your computer because of the sandbox. And of course, it's zero knowledge on Hypervault's part. There is no server-side component. Also, it's easy to use. Could be really great for non-technical users. Offline, as I mentioned. And as I mentioned, it's always usable. It's always going to be, because the data and the software go together, are in one package, you're never going to get outdated. So basically in conclusion, Hypervault, really simple file encryption. Use it for data at rest encryption, not data in transit encryption. Any questions? A little bit. It's not, so you cannot create a Hypervault on mobile, but you can decrypt them. But I've been playing around with trying to support that more. Right now I'm not officially supporting mobile, but it does work, at least for some tests I've done. Yeah. And some of that's not some of the functionality of like selecting files and stuff didn't even seem possible. So yeah. Any other questions on that? I haven't tested like IE6 and all of that. There probably are. Well, so okay, actually, I should say it uses a lot of HTML5 stuff. So if it doesn't support HTML5, it's not going to work. And a lot of that was needed to do things like the file downloads and selecting, and some interesting functionality like that. As a side note, it was also kind of interesting. It was kind of an interesting app to do because, this stuff used to not be possible to do, like this whole client-side file I/O in a web app. And it's also kind of interesting from the perspective that it's all self-contained. And there could be any number of other interesting apps that people might come up with that might follow that same model. So some cool stuff that HTML5 has given us, basically. Any other questions on that? Okay, not much time, so I'm going to move right along to the next miniature talk. And we're going to talk a little bit about tunneling. So this is kind of a topic that I would assume probably most people here would have some pretty good knowledge on. It's kind of low-hanging fruit from a securing yourself perspective, but also really valuable low-hanging fruit. So what is tunneling first? It's a term that seems like it's thrown around a good bit and sometimes has different meanings, but basically it's just wrapping a protocol in another protocol. Typically one that's not meant to be wrapped in that protocol though, right? So in any kind of network traffic, there's always almost always multiple layers of protocols. So for instance, in this case, I actually have, you guys probably can't see that very well. I'll go to the next slide, which colors also are kind of bad on. Anyway, you can probably see at least the red. So like this is a ping packet, and there's an outer level Ethernet header, and then that wraps an IP packet, and then that wraps an ICMP packet for ping, and that has its own raw data. Obviously things like TCP/IP, you got TCP wrapped by IP. So wrapping of protocols is something that's common. tunneling is typically when you wrap one protocol with another protocol that was not meant to be encapsulated by that. So an example would be, let's say you have some custom binary protocol, and you want, for instance, you might be wanting to get that out of a restrictive deep packet inspecting firewall or proxy, which only allows, let's say, HTTP. Well, you can wrap your binary protocol in HTTP protocol, and then it'll let it go out. So that's kind of what tunneling is. So today I'm going to talk about probably just, well, we'll try to go through these really fast. But the three kinds are HTTP, SSH, and DNS tunneling. So HTTP tunneling, as I was just making reference to, is where you're wrapping some other protocol inside of HTTP. There's two ways there's kind of two main methods to doing this. One is this HTTP connect method, where it basically makes use of the fact that to allow HTTPS, proxies do allow arbitrary data through if you use the HTTP connect verb. So you can connect to the proxy, and then you send it a HTTP connect request, which asks it to connect to another server. If it allows that, if the proxy you're behind allows that, it'll just allow arbitrary binary data between there. So that's something that can work. We're not going to talk about that a lot. I posted a little link to a library that lets you do that. But the other type is basically tunneling, basically what we typically mean by tunneling, where you're wrapping some other protocol inside of HTTP. So I want to talk about that a bit. So first, there's multiple ways you could do this. There's multiple ways you could wrap some other protocol inside of HTTP. Ultimately, you just have to transmit your underlying protocol you want to transmit in a way that is valid HTTP. So you could put all the data, for instance, in get URLs, in HTTP get URLs. You could do that. You could even put the data in. You could put it. Well, the common way is to put it in a post body, but you could even put it in like a user agent string, which would be kind of a weird way to do it. But you could do it. It'd actually be kind of like a form of tunneling and steganography at the same time. But just wanted to mention it's, you could do it multiple different ways. So tunneling through HTTP, if you have two pieces of software that do HTTP tunneling, they very likely may not be compatible, because there's all kinds of ways you could implement this. The way I wanted to show, actually, so I was doing some testing recently where I was wanting to get this binary data out of basically Blue Coat proxy, and it basically was doing deep packet inspection on our traffic, and it would not let our binary protocol out. Well, I found that you can actually just prepend your binary data with a valid HTTP header, and it's as simple as that for HTTP tunneling that binary data to get through that restrictive proxy. So this is like a really, really poor man's version of HTTP tunneling. It's because actually, well, I guess it could be valid, but it's very lightweight. It's not even wrapping. It's just prefixing your data with the header. And I was setting the things I was setting correctly was like the host and the content length. I would guess probably if you set those incorrectly, I would guess some of the restrictive proxies probably would not let it through. So anyway, it's something really simple you can do. And why would you want to do such a thing? Well, probably data exfiltration might be a way, or maybe you have some app that you're writing that you just want to make sure it can always get out. That'd be appropriate uses for this kind of thing. So going on, SSH tunneling. So actually, I was kind of curious, who all here has done SSH tunneling? Okay, maybe 30% of the people. So this is super low-hanging fruit, but something that I think is extremely valuable to a lot of people, potentially. So what it does is you basically have to have your own SSH server or an SSH server somewhere on the internet that you have an account on. And if you have that, you can run a single command on your local computer, and that sets up an SSH tunnel and a local SOCKS proxy, which you can use. So what that looks like visually, hypothetical scenario. At work, you're behind some restrictive proxy or firewall, and they don't want to let you go to, maybe some Bitcoin exchange to trade, let's say, or some other website that, is not bad to go to necessarily, but they don't want you going there. Also, potentially, what if they're looking at the traffic you're going to? What if you want to go to Facebook.com? Maybe they even allow that, but you don't want them knowing you're going to Facebook.com. Hopefully, you're doing something for a valid business reason. I'm just giving examples. Under all these scenarios, SSH tunneling could help you out. So you basically set up this encrypted channel between your computer and your SSH server. Now, one big thing to note. Okay, so you do that, and all the traffic that you direct toward your local proxy gets tunneled through SSH, through this encrypted channel, over to the SSH server. Now, one big thing to note. So this can provide both privacy, as in your employer can't know what you're doing, or whatever firewall you're behind. It can't see your traffic because it's encrypted. And also because it's encrypted, it also gives you some security, but only to a point. So after that traffic leaves your SSH server and goes onto the internet, it's not encrypted at that point, and it's not private or anonymized or anything like that. So you got to keep that in mind when you're doing this. It does provide encryption, but only between your client, your computer, and the SSH server. But if you're trying to access services on that SSH server, it does give you full encryption, end to end. So this could be great if you might even be using a protocol that is actually unencrypted. But you could do that securely if you're using SSH tunneling. So I already went through that. So basically the only command you need to know to do this is this one right here. So SSH-D, this is the port. This is the local port that you're wanting to set up a SOCKS proxy on. And then your username at your sshserver.com. And actually, let me try to do a quick little demo. I think I got time. So I'm going to set up a little server. All right, so right there, I just did it. I just set up an SSH tunnel. Now, to use it, I want to show what that could look like. So if I'm just going to curl this URL here. It basically just gives me my IP address. So if I do that, you can see I don't know if you can see that. I can't zoom in on here. Anyway, it's yeah, I can't zoom in. 166 dot something, right? Well, if I tell curl, hey curl, use my local SOCKS proxy running on localhost port 5000, and I do the same command, I don't know if you can see that, but the IP changes, so it's a different IP. So it looks to the outer internet like I'm at a completely different, IP. So, it's a proxy tunnel. It's great for, just some basic security and privacy and power if you're, if someone's trying to prevent that. And the last type of tunneling I want to talk about really briefly, because there's not much time, is DNS tunneling. So this is so DNS tunneling. One really great thing about it is almost every network will allow outbound DNS traffic. So even if they're they're trying to restrict your internet access on pretty much everything, they typically still allow outbound DNS. And so what you can do is you can actually tunnel you can actually set up a local a DNS tunnel, and you can actually then do an SSH tunnel inside of that. Then you have a generic SOCKS proxy, and you can tunnel all your traffic through that. So you could potentially get free internet if someone was being restrictive. So I'm not going to do a demo of this. There's not enough time. But the software that I've used for this is it's called Iodine, and it's just an open source project on GitHub. You have to set it up on your server and on your client, and you'd have to do this beforehand, of course. Like if you were, so I'll give you an actual scenario. I was traveling and I was curious, could I get free internet on an airplane? While by doing DNS tunneling, and it turns out I could. They did allow, I actually did this on a flight, and I was able to get, without paying for the internet or anything like that. I was able to ping a URL and get there. I'll say though, it was so slow, it would not be really worth it. It was to retrieve a URL, I think I did that API to get my IP address, and it took 4 seconds or something like that. So it's not really practical, at least if you're on an airplane. But it very well could be in other scenarios where the internet's faster and the ping rate's faster. So it was interesting. And so just we're not going to demo it, but you can kind of see I did a Wireshark capture of what it looks like when I'm browsing just regular HTTP inside of a DNS tunnel, and all you see is a bunch of DNS packets, which is exactly how it should look, and that's how it would look to any proxy or firewall that you're behind. It's, as far as I know, it's probably one of the most surefire ways of getting out of that kind of restrictive scenario. And it also could be used, so you could use it for that, like trying to get free internet when they're not offering it. But you could also use it to, let's say you're writing some software and you want to make absolutely sure that it's going to be able to, say, phone home. Well, DNS tunneling would be a great way to do that. And actually, I was doing some sniffing recently, and I noticed I think that Skype actually does this. I don't quote me on that, but I saw Skype traffic going out on UDP port 53, which is DNS. So I suspect that some apps like Skype actually do this. And one other side note, I have found it's not the DNS tunneling, at least with Iodine, the app I've used. It seems pretty unreliable. I've had some trouble, it's been kind of finicky. It works for a little bit, then it closes. Let me see. I do have. Well, I can open this right here. So I have a little guide on my blog. If you just Google for Caleb Madrigal DNS tunneling or something, it would come up. But just so some failures I ran into. I could not get this working when the version of Iodine on my client and my server were not exactly the same. So I actually ended up having to clone the repo on my client and on my server, build it, and then I was able to get it to work. I also was not able to get it to work going from OS X to Linux. I was only able to get it to work when my local client was Linux. So I was running a Kali VM on my Mac, and I was able to get that to work, but I could never get it to work on OS X. That's all I have for you today. Are there anyone have any questions on any of that? It could be on Hypervault or on the tunneling, I guess. All right. Thank you.